Hey there, I'm back. Here we are, section 5.3, and we're going to actually graph some of these rational functions. They get a little crazy, so we're going to kind of build into it. The six main things that we're going to be looking for are the y-intercept. We talked about this in the previous video. The y-intercept is where x equals 0. The holes are where linear factors cancel, and we talked about that in previous videos as well. X-intercepts when y equals 0. Vertical asymptotes, we set the denominator equal to 0. We're presuming that we've gotten rid of the holes already, because you also set those equal to 0. And then solve for x. Horizontal and slant asymptotes. The horizontal asymptote is going to be 0. Once again, here are the three cases. Horizontal asymptote when the numerator degree polynomial is smaller than the degree in the denominator. Then it's y equals 0, or the x-axis, which is the horizontal asymptote. If it's the same degree, then the lead coefficients are going to take over. And we'll see some examples of that here in just a minute. And then the signs of the graph. I'll explain more about that as we get to specific examples. So the behaviors of a graph around a vertical asymptote is going to be something like this. They're either going to both be going to positive infinity or maybe possibly going in opposite directions here, or maybe even the same direction. Behaviors around horizontal asymptotes are going to be the same. However, and here's a slant asymptote, it is possible to cross a horizontal or a slant asymptote. You never are able to cross, your graph is able to cross a vertical asymptote. But horizontal asymptotes, that does happen occasionally, and we will see an example of that here in just a minute. So here we are, and we're going to actually graph these things, and we're going to go through our steps here. So here's our function, and first off, I'm going to notice that we have the same degree. So that's going to matter there. And very nicely, we've factored it here. And we're going to start with the y-intercept, where x equals 0. And you can see when x equals 0, we get 24 over negative 14, which reduces very nicely to negative 12 over 7. So this is where the graph is going to cross the y-axis. So negative 12 over 7 is about there on our graph here. Are there any holes? Well, we factored it out and nothing reduces, so the answer is no. There are no holes in this particular graph. X-intercept, that's basically set the whole thing equal to 0, or where the numerator equals 0. And we can see when the numerator is going to equal 0 at negative 6 and at positive 2. So you can see here at negative 6, it's crossing, and at positive 2, it's crossing. The vertical asymptote, the denominator is going to equal 0 in two places in this case. We have at positive 7 and at negative 2. And here's x equals negative 2. You can see we have a vertical asymptote here. And we can again see that behavior where infinity is involved. And here at 7, we have the same idea going on, where infinity is negative infinity here, positive infinity there. And do we have a horizontal asymptote? We do. It's at y equals negative 2. Here's y equals negative 2 on the graph. And you can see this graph is getting, as we go out to infinity, it's getting closer and closer and closer. This one also is getting closer and closer and closer. I do want to point out that this part of the graph does cross here. The way we would find that exact point is we would set y equal to negative 2. So if we set that whole thing equal to negative 2, we would solve the equation and find that exact point as we do that. We're not going to get into that for this particular discussion point. Here's our second graph. And right away, I'm going to notice the degree in the top is bigger than the degree in the bottom. That means that we're going to have a slant or an oblique asymptote. We'll get to that. Here it is in factored form. We'll start over again. Y-intercept. That's when x equals 0. So when x equals 0, I'm going to get negative 9 over negative 2, which is 9 over 2, which is right here on the graph. That's right where it crosses. Are there any holes? Nothing reduces out, so there are no holes once again here. X-intercept was when the whole thing equals 0, or basically when the numerator equals 0. That's going to be at negative 3 and at positive 3. So here's negative 3 and positive 3. You can see graph crosses. Vertical asymptote, that's going to be when x is equal to 2. X equals 2. And so here's our vertical asymptote at x equals 2. You can see it right here. And you can see the graph is getting closer and closer, but never quite touching. And our slant asymptote, that's where it gets a little nutty. We do our long division. Be careful, there's a missing 0 there. You're going to have to shift things over. If you were to do synthetic division, you would have to put a 0 in there as well. After you divide it out, what's taking over is this line right here, x plus 2. And here's our remainder. Again, you can see as x gets really, really large, it just becomes x plus 2. So our line, x plus 2, so the y-intercept is at 2, slope is 1, so it's up 1 over 1, so there's our slant asymptote. And you can see our graphs are getting closer and closer and closer to it. Next up, here's our third example. So we'll start again. Here it is factored, and you'll notice that we can actually reduce the x plus 3's out of this one. That means we're going to have a hole in it. We'll come back to that. The y-intercept is when x equals 0. When x equals 0, you can see it. That's negative 21 over 15, which reduces to negative 7 over 5. That's going to be right down here, negative 7 over 5. There's our y-intercept crossing the y-axis. The hole. So once we reduce out x plus 3, they're gone, and we're left with just this here. Now what we do is we take negative 3 and we plug it into here and here. And after we plug in negative 3 into here and here, we end up with negative 13 over 2. You can work that out to verify that. And so our hole is at a negative 3. Here's negative 3. Negative 13 over 2 is negative 6.5. So that's way down here, negative 6.5. And you can see the hole in the graph. Next up, the x-intercepts. Again, that's when you set the whole thing equal to 0. And you can see one of the x-intercepts is was going to be where the hole was, so that one's canceled out. So it's just the numerator in this case. 2x minus 7 equals 0. When we solve for x, we get 7 over 2. You can see the 7 over 2 there. 7 over 2 is 3.5, and you can see at 3.5 we are crossing the graph right here. Vertical asymptote, where's the denominator equal to 0? We don't have to worry about the x plus 3. We've already handled that with the hole. So when x equals negative 5, we definitely have a problem. And that's where our vertical asymptote is going to be. And here we are at negative 5, x equals negative 5. And you can see the graphs are getting closer and closer and closer to that vertical asymptote, but they will never cross. Horizontal asymptote. Notice that the degrees are the same in this case. That means the lead coefficients take over. That's going to be 2 over 1. So that's why y equals 2 is our horizontal asymptote. And you can see that right here. And you can see it's getting closer and closer, closer and closer to that horizontal asymptote. The third piece that we need to keep, the sixth piece that we need to keep in mind is the signs. So I mentioned that before, and we haven't needed to use it yet. So if I pick any point to the left of negative 5, say negative 6, and plug it into even here, the sign is going to become positive, meaning SIGN. When I plug in a negative 6 there and there, it's going to give me a negative over a negative, which reduces to a positive. So all of the values on this side of negative 5 are going to be positive. That's how I knew the graph was behaving like this over here. Between negative 5 and 7/2, that's between our vertical asymptote and our, actually this should be 2 for our, where it's crossing the x-axis. And you can see if we pick something between negative 5, let's pick 0 for example. Do you see I get a negative value? So you can see we're below. And I'm sorry, this should be 7/2. I was mistaken on that. And so there, before 7/2, we're below the x-axis. If we pick something bigger than 7/2, so let's pick 4, for example, and plug it into here. What's going to happen is all of those values, all those y values, are going to be above the axis. So we're positive up here. All right, we have a few more examples. So we want to graph a function with the following characteristics. So now we're given characteristics instead of just a function. Horizontal asymptote at 2. Here we are, horizontal asymptote. We have a vertical asymptote at negative 1. Here's negative 1. And at positive 3. Here's positive 3. There are no holes. X-intercept at 5, 0. Here we are, 5, 0. Y-intercept at 0, negative 4. That's down here. It starts before negative 1. That's here. We're positive. We're above the x-axis. Between negative 1 and 3, here's negative 1 and 3, we're negative. We're below the x-axis. From 3 to 5, so here's 5, here's 3. From 3 to 5, we're negative. We're below the x-axis. And then after 5, we're positive. We're above the x-axis. Let's take a look at number 5 over here. So we have a slant or an oblique asymptote. That is 2x minus 3, so it's crossing at -3, up 1 over 2. There's our line. No vertical asymptotes. There's a hole at 4, 1. So at 4, 1, there's our hole. X-intercept at 3. Y-intercept at -5. That's down here. And then you can see it's getting closer and closer and closer to the slant asymptote. Last page. So we are going to find the function based on the graph. So I can see we have a horizontal asymptote here at y equals -3. So there's my -3. This also means that the degree is going to be the same because the -3 means that I have a horizontal asymptote. And the lead coefficients are here. I'm going to notice that it crosses at 3. It crosses at 2 as well. So when x equals 2, you can see I'm at 0 there. Also, I have a vertical asymptote at -2, so I know that's going to be in the denominator. So there's my whole graph. Number 7 is a lot more complicated. Let's focus on it for a minute. So we are going to find the function that behaves this way. First off, I'm going to notice that there's a horizontal asymptote at 2. That tells me that the degree are going to be the same in the top and the bottom. Also, I have 2 vertical asymptotes. I have one at -2. I have one at +1. So you can see I'm here. Since the graph is on opposite sides of the x-axis near the vertical asymptote x equals -2, the exponent on that factor will be odd. Since the graph is on the same side of the x-axis near the vertical asymptote x equals 1, the exponent on that factor will be even. So here's why x minus 1 in the denominator is going to have an even exponent. It's going to be squared most likely. It could be 4th power, we don't know, but we'll just make the smaller of the two, the even. We know it crosses at 3, 0. So there's the only place it's crossing there. We now look to the horizontal asymptote, y equals 2. There's my 2. And the degree has to be the same in the top and bottom. And it's going to have to be one where there's no 0. So x squared plus 1 will never be 0, ever, under any circumstances. And if I square that, that makes the degree 1, 2, 3, 1, 2, 3 the same. I'm going to let you study that one. That one gets quite complicated.